Guys, this problem is different from the previous problem, from the way that it is fixed on both sides. Since it is fixed on both sides, it's quite different. So this could be imagined something like this. Idana, suppose, now to imagine, this is section 1, this is section 1 and this is section 2. This is section 1, section 2. Now you try to put this arrow mark like this. You put the arrow mark like this. And on section 1, what is the load acting on the right hand side? It is minus 10 kilonewton. And is it the only load acting? Okay, definitely we call it as resistive forces. Last time this was not there. Last time this was not there. So therefore you could easily escape. Okay. So now definitely there is an issue that there is a resistive force here. There is a resistive force here. It is not just minus 10 kilonewton. There will be what is called as a reaction force. Now you can imagine that since this is actually trying to pull like this, let us imagine that if you are trying to pull like this, it is as good as this. Now this end should be able to apply a reactive force in this way. Okay, am I true or not? Yes, I mean, am I right? Okay. Am I right? This should be like this. So let us call this end as B. Let us call this end as B. Let us call this end as B, which produces a reaction at end B. Call this as RB. Okay. Let us call this end as A. Let us call this end as A, which produces a reaction force which is like this. Let us call this RA. So both of the ends produce a reaction force, but I don't know how much. Guys, is it like, now it is actually 10 kilonewton. This will produce 5 kilonewton. This will produce 5 kilonewton. Is it true?
No.
Why? Why do you think each of this will not produce 5 kilonewton? Suppose if I add a metal like this, and this is also steel, this length, two lengths are same, and then if there was a 10 kilonewton force like this, and if it was arrested on both the sides, then I would have definitely written that this end produces 5 kilonewton. This end produces 5 kilonewton, I would have written, because this material is like a spring of same stiffness, because this is also steel and area is same, length is same, and here also material is steel, length is same, area is same, and therefore it is also like a spring of the same size, same length, everything. If you got a spring like this, and if you try to apply a load on the spring like this, if you apply a load on the spring like this equal to 10 kilonewton, then definitely both the sides of the spring are of the same stiffness. So it will oppose by 5 kilonewton, this will oppose by 5 kilonewton. Suppose if this is copper, copper is not as stiff as steel. So on the left hand side you will have a very stiff spring. And on the right hand side you will have a very soft spring. Then in that case, if you apply a load like this, 10 kilonewton, which spring will transmit more force onto the ends? The stiffer spring. So definitely this will take more reaction load, more than 5 kilonewton. The softer spring will produce lesser reaction force like 3 or 4. So therefore you should not actually directly write this as 5 and 5. You should actually call it as RA and RB and solve for it. Okay? People may think, since it is exactly at the center, this 10 kilonewton is shared by left hand and right side. 10 ನ್ಯೂಟನ್ ಲೆಫ್ಟ್ ಸೈಡ್ ಎಂಡು ಮತ್ತು ರೈಟ್ ಸೈಡ್ ಎಂಡು ಎರಡು ಈಕ್ವಲ್ ಶೇರ್ ಮಾಡಿಕೊಂಡ್ರೆ ಆಗ್ಬಿಡ್ತೈತೆ ಅಂತ ಹೇಳಿದ್ರೆ ಆಗಲ್ಲ, ಬಿಕಾಸ್ ದಿಸ್ may be different, this may be different, the area is different, length is different, and all this. Okay? So we can't solve like this. I am giving an introduction to this. Why we are actually not actually considering the equal loads on either ends, and we are not solving it. Okay? Guys, we said that this is the section 1. Section 1 has actually load of minus 10 kilonewton, and then it is not just minus 10 kilonewton. Let us say because of this force, it produces the reaction force at this end. You can replace this. You can replace this by RB. You can replace this by RB. So you have to call this as RB. And people may actually do a mistake, and here they can call it as RA. So I actually suppose if some people call this as reaction force minus RA, then it will be wrong because you are trying to introduce two unknowns. So what you do is either you try to only express this in terms of RA or RB. Suppose if somebody doesn't want to see on the right hand side of this part. Suppose if I see on the right hand side of part, I get this minus 10 and RB. Okay, I don't want to do this. Suppose if I see on the left hand side, now I put this arrow mark like this, I'll call this as minus RA. Ikkada minus RA hakidre, then I will directly say this as minus RA. Okay? Don't put RA and RB both. Just express in terms of one. And again, when you come to this section 2, don't see to the right side, because if you see to the right side, you will get RB. See onto the left hand side of the part. ಇಲ್ಲಿ left side ನೋಡಿ ಏನೇನು forces ಇದೆ? One is actually 10 kilonewton. This is plus 10 kilonewton, and then minus RB. The same thing you have to write on the right hand side. Minus RA plus actually 10 kilonewton. Okay. Now let us find out the total deformation with this. So can you expect what would be the total deformation? ಎಷ್ಟಾಗುತ್ತೆ deformation ಇಲ್ಲಿ? So deformation ಎಷ್ಟಾಗುತ್ತೆ because of this force? 0. Asmit is saying the total deformation of part 1 and part 2 will be 0. ಯಾಕೆ?
Because both ends are fixed.
Both ends are fixed. If one elongates, suppose if this elongates, because of this force, copper elongates, but steel will get compressed by the same amount. The length by which copper expands, by the same amount, steel will get compressed. So definitely the total elongation will be 0. So let us write the individual equations dl1 and dl2 and add it and equate it to 0. Okay, that way we will be able to find out RA and RB. Basically in this type of problems, they will not ask you to find out dl. Why?
Because it's
dl is 0. What they will ask? They will actually ask you to find out reaction forces RA and RB. Okay, so I know this reaction force minus RA. For this, can you write down dl1? Now what is the formula? P1, L1, A1, E1. What is actually P1?
RA.
It is minus RA. Minus RA into L1 is how much? 50 mm. And what is A1? A1 earlier you are calculated.
706.95.
706.95 mm square. And E, now what is E? Is it C?
Yes.
Okay, is it C? Okay. So Young's modulus is how much? 200 GPa. Okay. So can you find out the answer here? You can't find out the answer because carry is not there. Okay, leave it as it is. Okay, leave it as it is. And then can you find out DL2? So DL2 is similarly P2 into A2 E2. So load on the section 2 ಏನು minus RA plus 10 kilonewton. Nice. You write this as like this. Okay. Minus RA into plus 10 kilonewton into ಎಷ್ಟು length ಇದ್ರದ್ದು
20 length 30
length is 30 mm.
30 by 3 point.
So this is area 2 is 314.15 mm square. Earlier you found out. And next modulus is it is not 200, it is 100 into 10 to the power of 3 Newton per mm square. You can find out. I think let us see whether we need this or not. Can we add this? Suppose if you want to find out, and I think you can't find out, but you will express this in terms of RA into some number. And here you can express this into minus RA into some number. Okay, right now let us not worry about this. Okay, now we know that DL, the total deformation DL is equal to DL1 plus DL2, which is actually equal to 0. It is actually equal to 0 because both ends are fixed. There can be no sum of deformations. It cannot be a positive number because one has to increase and the other has to decrease. So DL1 is actually minus RA into some number. ಈ ನಂಬರ್ ಎಲ್ಲ ಸೇರಿಸ್ಬಿಟ್ಟು ಒಂದು ವ್ಯಾಲ್ಯೂ ಕಂಡುಹಿಡಿಯಬೇಕಾಗುತ್ತಾ? And here also you can split this. You have to split this. You have to split this as minus RA into 30 mm. Minus RA into 30 plus this 10 into 30 because this is, you can't, then 314.15 into 100 into 10 to the power of 3 Newton per m square. So can you actually find out this number?
The first one
ಇಲ್ಲ ಏನೋ ಇಲ್ಲ ಏರ್ಪ್ಲೇನ್ ನೋಡ್ಗೆ ಹಾಕಿದ್ದೀನಿ ನಾನು ನಿಮ್ಗೆ
sir, first one 3.53 into 10 power minus
3.53
into 10 power minus 7 sir.
minus 7 minus 7 mm minus 7 ಬರುತ್ತೆ ಅಷ್ಟೊಂದು
minus 7 okay 7 sir.
Okay, minus 7 mm. And here, can you find out this? So, minus RA into 3.53 into 10 to the power of minus 7 mm plus this one is minus RA into 30 So this is plus again because this whole number you are actually trying to add this. ಇದೆಲ್ಲ ಆಡ್ ಆಗುತ್ತೆ, ಇದೆಲ್ಲ ಆಡ್ ಆಗಿಬಿಟ್ಟು ಒಂದು ನಂಬರ್ ಬರುತ್ತೆ. ಎಷ್ಟು ಬರುತ್ತಿದ್ದು ಬಿಕಾಸ್ ದಿಸ್ ಹೋಲ್ ಥಿಂಗ್ ಎರಡು ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಗೊತ್ತಾಯ್ತಾ? ಬ್ರ್ಯಾಕೆಟಲ್ಲಿದೆ, ಇದಕ್ಕೂ ಎರಡಕ್ಕೂ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು. ಐ ಥಿಂಕ್ ಯು ಡೋಂಟ್ ಮೇಕ್ ದಿಸ್ ಮಿಸ್ಟೇಕ್. ಸೊ ಎಷ್ಟು ಬರ್ತಿದ್ದು? ಇದು ಎಷ್ಟು ಬಂತು ನಂಬರ್?
9.5492
-5 ಅಂತ ಬಂತಾ? -6 ಅಂತ ಬಂದರೆ ಇದನ್ನು -7 ಅಂತ ಮಾಡೋಕ್ಕೆ ಏನು ಮಾಡಬೇಕು ಅಂದರೆ ಇದನ್ನು ಇಲ್ಲಿ 95.4 ಅಂತ ಮಾಡ್ಕೊಳ್ಳೋದು. ಈ ಕಡೆ ಒಂದು ಶಿಫ್ಟ್ ಮಾಡಿದ್ರೆ ಇದು ಮೈನಸ್ ಅಂತ ಹಾಕ್ಬೋದು. ಸೊ ಇಟ್ ಇಸ್ ಬೆಟರ್ ಯು ಮೇಕ್ ಇಟ್ ಬಿಕಾಸ್ You can,
10 into 300.
so this is
30 into 10 into 5.
ಇಲ್ಲಿ ಮೈನಸ್ ಆಗಿ ಹೊರಗಡೆ ತಗೊಳ್ಳೋಣ. ಇಲ್ಲಿ ಮೈನಸ್ ಆಗಿ ಹೊರಗಡೆ ತಗೊಂಡ್ಬಿಟ್ಟು ಯು ಕ್ಯಾನ್ ರೈಟ್ ಇಟ್ ಆಸ್ minus RA minus 3.53 into 10 to the power of minus 7 ಮತ್ತೆ ಇದು minus 30 ಇಲ್ಲಿ ಮೈನಸ್ ಮೈನಸ್ ಇದೆ, ಸೊ ಈ ಮೈನಸ್ ಇರೋದ್ರಿಂದ ಮೈನಸ್ ಆಗಿ ಹೊರಗಡೆ ತಗೊಂಡಿದ್ದೀವಿ, ಮೈನಸ್ ಆಗಿ ಹೊರಗಡೆ ತಗೊಂಡಿದ್ದೀವಿ. ಸೊ ದಿಸ್ ವಿಲ್ ಬಿಕಮ್ ಪ್ಲಸ್, this will become plus, and again this will become 95.4 into 10 to the power of minus 7, which is equal to 0, which is equal to 0. Somewhere I gone wrong, I think.
Sir, minus RA ಅದೇ ನಿಮ್ದು 30 ಆಗಿದೆ
Guys, here where I actually went wrong was, guys, here where I went wrong was, you actually make this, whatever is outside this, actually find out a value for this. Now what is the value that you got for this one? Minus RA in plus 10 into, is ಎಷ್ಟು ಬಂತು ಇದು value?
9.54 into 10 to the power minus
9.54 into
10 to the power minus 7
into 10 to the power of
minus 7.
So you got this value here. Now add this two. Now you can get this properly. So now we have got this. So now this is minus RA into 9.54 into 10 to the power of minus 7 plus 10 into 9.54 into 10 to the power of minus 7. So here you can actually take RA common in this because it's minus and minus. You can take this RA common, which is actually minus and minus. So you can add this 3.53 into 10 to the power of minus 7 plus 9.54 into 10 to the power of minus 7 and plus 10 into 9.54 into 10 to the power of minus 7. So since it is minus here, since this is minus here, you can take it on the right hand side. You can take it on to the right hand side. So this becomes minus RA into, you get some number here. 3.54 into 9 point, it becomes 13.04 ಅಲ್ಲ, 3.54, so 3.5 plus 9.54.
Sir, 1.307.
Will it come
Sir, ಅದು
13? So it comes 13.04 into 10 to the power of minus 7. This should be equal to 10 into 9.54 into 10 to the power of minus 7. So here, since this comes down, you can get this down to get minus RA. You can get this down to minus RA, where this comes here as 13.04 into 10 to the power of minus 7. And you get the answer as how much?
7,299.
7,000?
299 newtons.
299 newtons. Did you get this? I doubt. The 10.94 and 10 into 9 ಅಂದರೆ 90 ಬರುತ್ತೆ. 90 divided by 13 ಅಂದರೆ ಅಷ್ಟು ಬರ್ತದಲ್ಲ ಸಮ್ಮರ್.
ಸರ್ ಅಲ್ಲಿ 10 to the power 3 ಬರುತ್ತೆ ಕಡೆ. ಅದು ಕಿಲೋ ನ್ಯೂಟನ್ಸ್ ಅಲ್ಲಿ ಇರೋದು ನ್ಯೂಟನ್ಸ್ ಇಲ್ಲ ಸರ್.
ಇದು ಎಷ್ಟಿದೆ 10 to the power 3
ಸರ್ ಅಲ್ಲಿ
10 to the power
ಅಲ್ಲ ಬಿಕಾಸ್ ಐ ಆಮ್ ನಾಟ್
ಸರ್
ಕ್ಯಾಲ್ಕುಲೇಟ್
ಅಲ್ಲಿ ಲಾಸ್ಟ್ ಸ್ಟೆಪ್ ಇದೆ ಸರ್.
ಲಾಸ್ಟ್ ಸ್ಟೆಪ್ ಇಲ್ಲ
ಅಲ್ಲಿ
ಅದು ಮೇಲಿನ ಸರ್.
ಇದು
ಮೇಲಿನ ಸ್ಟೆಪ್ ಅದು ಮೇಲಿನ ಸರ್.
ಹಾಂ
ಅಲ್ಲಿ
10 to the power 3 ಬರುತ್ತೆ.
ಇದಾ ಓಕೆ ಮತ್ತೆ ಅದನ್ನ ಹೇಳ್ಬೇಕಾಯ್ತು.
ಅಲ್ಲ ಸರ್.
ಸರ್ ಆದಾಗ ಕರೆಕ್ಟ್ ಇದೆ ಸರ್. ಕರೆಕ್ಟ್ ಇದೆ.
ಇದು ಸರಿ ಇದೆ ಬಿಕಾಸ್ ಯು ಗೇವ್ ದಿಸ್ ವ್ಯಾಲ್ಯೂ ಸೊ ಐ ಸೆಟ್ ದಿಸ್. ಸೊ ಇದು ಬಂದು 10 to the power of -7 ಇದೆಯಾ?
ಇಲ್ಲ ಸರ್.
ಸೊ ಹಂಗಿದ್ರೆ 10 to the power of -7 ಇದ್ರೆ ಈಗ ನೀವು ಇಲ್ಲಿ ಈಕ್ವಲ್ ತೊಗೊಳಕ್ಕಾಗಲ್ಲ, ನಾವು ಎರಡನ್ನ ಆ್ಯಡ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ, ದೆನ್ ಯು ಶುಡ್ ಬಿ ಕೇರ್ಫುಲ್, ದೆನ್ ಯು ಶುಡ್ ಆ್ಯಕ್ಚುಲಿ ಆ್ಯಡ್ ಇಟ್ ಸಪ್ರೇಟ್ಲಿ.
ಸರ್ ಅದು ಮತ್ತೊಂದು
ಓ ಅದು ಸಪ್ರೇಟ್ ಅಲ್ವಾ? ಇಟ್ಸ್ ಓಕೆ, ನೋ ಪ್ರಾಬ್ಲಮ್. ಓಕೆ, ದ ಸೇಮ್ ಥಿಂಗ್ ಗೋಸ್ ಹಿಯರ್, ನೋ ಇಶ್ಯೂಸ್. ಆ್ಯಂಡ್ ಹಿಯರ್ ವಾಟ್ ಯು ರೆಟ್ ಇಸ್ -3 ಆಯಿತು, -3. So once it goes above, it becomes 10 into 9.54 into 10 to the power of, ಇದು ಮೇಲ್ಗಡೆ ಹೋದರೆ it becomes 10 to the power of 7. So you get this, and finally you get the answer as minus RA is equal to 7299. 7299. Okay guys, once you have got this, definitely you can get this RB. You can get this RB, which is actually the remaining part. So you know that RA plus RB is equal to 10 kilonewton. So if you know RB, so you, okay, since you know RA, which is actually 7299 newtons plus RB, so this is equal to 10 kilonewton. So RB is equal to 2701 newtons. So you know the directions here, so you don't have to worry whether it's minus or plus. So you just find out RB because both of this are acting on the right hand side. You don't have to assign any issues to this.
ಈಚೆದಾಗ ಪ್ಲಸ್
ಯಾವ್ದಪ್ಪ?
ಈಗ ಮೈನಸ್ ಪ್ಲಸ್
So this becomes 10,000.
ಅದು ಕರೆಕ್ಟ್ ಅದು ಆನ್ಸರ್.
So answer plus.
ಅಲ್ಲ ಸರ್ 17,280
ಇಲ್ಲಿ.
ಸರ್ ಇದು ಮೈನಸ್ ಇಂದ ಆಚೆ ಹೋಗುವ ಪ್ಲಸ್
Okay, sorry. I think you don't have to worry about this minus sign. Sorry. You don't have to worry because we are only calculating this as minus RA here because we wanted to show that it's on the opposite side. You have to take the mode value which gives this and find out this RB, which is actually 10 kilo. This is 10 newton. This is 10,000 newton. You get this. I think the main complexity here is
ಪೆಂಡಿಂಗ್ ಆಗಿ
finding RA. I think finding RA. Of course, here suppose if you understand this concept of actually trying to give the load in terms of RA, and then there are two issues here in this problem. One is expressing this in terms of either RA or RB, and then next substituting this RA and making an equation and trying to mathematically solve this. Even I relied on you and wrote something wrong, and I actually messed up here. So please be careful, practice these problems once or twice, because even if you solve out of this and don't get the right answer, then you lose around 60% of the marks. Okay? So please practice this twice or thrice.
ಸರ್ ಆಬ್ಜೆಕ್ಟ್